Part 2 of the energy resources chapter, and it's going to be a very light video, and the explanation part won't take us any long. I just prepared a lot of past paper questions regarding the whole chapter by the end of it. Okay, there's one extra point that we didn't talk about last time, which we're going to add up right now, and the rest of it is literally everything we spoke about. We said that our energy resources they split into two sections. And the sections that we mentioned last time, we said that some of them are renewable, and we said some are non-renewable, if you remember with me. And then after that, we started naming the ones that are renewable, and we named the ones that are not renewable. We said for the renewable, we have a lot of them, starting off with such as wind energy, using wind as an energy resource, or using biofuels, using tides or tidal. All right, and we also mentioned hydroelectric. And we also had to talk about the last one, which was, we also said geothermal. And we also added two more. One of them was similar to tides and hydroelectric. We called it waves. It's pretty much the same thing. You can even refer to it as tidal if you want to. And the last one that we mentioned, which we said is unsimilar to all of these, we said solar energy. Okay, all of these are just resources you can use to convert into electricity. We said something is in common with the ones I'm going to highlight in yellow, which are this one, this one, this one, this one, this one, and this one. All of them work with the same mechanism, which is you have a turbine and your entire purpose is to spin the turbine. Okay, so all of them are just methods that spin the turbine and they turn the movement energy into electricity. Except for solar energy, they just take the energy straight from the sunlight, and it has a different way that we don't need to focus about, but it works in a different way to transfer the light energy into electric energy. Again, we described all of these to be renewable, meaning that they are energy resources that we can't spend more than there is in the universe, if that makes sense, and we can always make more easily. All right, either make more ourselves, such as biofuels, or they just exist naturally, such as the wind, the waves, the tides, geothermal, which is the heat underground, solar energy, which is sunlight. All of these exist without us even trying to make them come back. All right, now we defined another type. We called it the non-renewable, and under non-renewable we talked about two types of fuels. We said that fossil fuels are one of them, and the other type of fuel we spoke about was nuclear fuels. Okay, and the reason those are not renewable is we spend them more than they already regenerate in the world. So eventually, if we keep spending at this rate, both of them will run out. Look at the others that are all under renewable. Those don't have this run out thing happening with them. All right. Now we're gonna move on to another classification that scientists put on those energies, because the entire point of the second part of the chapter is making you decide which energy resources are better for you in certain situations. So you're gonna be basically doing comparisons. So you will have to compare. Usually in the questions, you're going to have to compare between two energy resources, naming the good things about one of them and naming the bad things about it, and then going to the second one, naming the good things about it and the bad things about it. So you're just doing a small comparison with advantages and disadvantages. All right. Now, one main factor that you need to ask yourself in all of the comparisons that you're going to make is the energy resource reliable? Or is it non-reliable? And the entire point of being reliable or not reliable, if you have this energy, if you have access to this energy resource, can you use it at all times? Or you can only use it sometimes because a condition is going to make it hard for you to use it. What I'm trying to say here is, if you look up at the examples that we have right here, wind, you can't use wind always, because what if in some day you wake up and there is no wind? It's not a windy day. The turbines are not going to spin, therefore you can't create electricity. All right, making this one not reliable. All right, talk about the second one, waves as well. You can't have waves all part of the year, so it's not reliable either. All right, solar energy, it's not reliable. Imagine if it's a cloudy day. The sun doesn't hit the solar panels. Therefore, there is no sun. Or imagine if it's raining, there is also no sun. Imagine if it's nighttime. You can think about many conditions making you not be able to use solar energy all the time, making them non-reliable. You think about fossil fuels, as long as you have them, you can use them at whatever time you want. Same with nuclear fuels. All right. Geothermal, it's very nice, but they don't usually compare it with reliability or not, because though some people can say it's non-reliable and others can define it with reliable. We'll see which way your book chooses. But the reality is you need a place that actually has hot layers underground. If it doesn't, then you can't use it. And if it does, then you can use it. But I just want you to know that the idea behind reliable and non-reliable is you're asking yourself, is this energy resource available to be used at all times or only sometimes? I'm gonna show you a table which displays to you a big comparison between the energy resources that we've taken, all of them, and it will help you answer a lot of past paper questions, because it's a repeated question where they give you a scenario of 2 ways to generate electricity, or they give you a place, they describe the conditions and you need to name the best ways that you can use to generate electricity in such conditions, or just basically give you a comparison and you need to say, oh, is this one reliable, is that one not reliable, is this one faster, what would I do in such situation? It's more of a thinking question. They're not hard once you understand how each one of them operates and you understand the reliability of it, the speed of it, stuff like that. So we'll see in a table, and we're going to focus on some important points when it comes to each energy resource. Starting off with fossil fuels, we're going to just go over each one of them. Fossil fuels are not renewable. They have the chance of running out. We end up spending them a lot in cars, in generating electricity in normal power stations. So fossil fuels will run out eventually, even though it's a long time from now. Okay, but they have a feature which is very nice to us. They happen to be reliable. Why are they reliable? Because as long as you have fossil fuels and you have a factory, you can generate electricity. You don't care if it's raining outside, you don't care whatever is happening. You have it, you can use it to generate electricity. As simple as that. And it says that it can produce large amounts of energy consistently and can respond to changes in demand. So if you like, the second part of responding to changes in demand is important, because if you want to generate a lot of electricity, you can do that by burning a lot of fossil fuels and using big turbines that spin. Okay, and if the demand is not much, there is no need for you to generate a lot of electricity. You can just burn less fossil fuels, which will make the turbine spin less. And once it's spinning less, then you're not generating as much. So depending on the demand, you decide how much electricity do you generate. Okay, which is a very nice feature when it comes to those. Okay, but again, you need to understand that every single energy resource that we're going to study is not perfect. All of them have good advantages, but they also have some stuff we call disadvantages, which are the bad things about it. You look at the disadvantages when it comes to fossil fuels, it starts reading out that fossil fuels are bad because they produce carbon dioxide, okay, which does global warming, okay, and some other stuff that it also gets produced, such as a sulfur dioxide, which causes acid rain, stuff like that. So you can just kind of like say that the problem with it is carbon dioxide, which does global warming, and it also causes acid rains. Those are bad things about you using a lot of fossil fuels or burning them, even though it's the most used energy resource that we have on the planet, but nothing is perfect. So those are bad things that it produces. All right. The second one we're going to talk about is nuclear energy. Again, it's very similar to fossil fuels. It's reliable because as long as you have some nuclear resources, you can use it to generate electricity. All right. And it also produces a large amount of electricity consistently, produces no pollution or CO2. So that's a good thing. The type of bad thing it does has nothing to do with CO2. Okay. And again, it can produce large amounts of energy with basically very, very, very little amounts of nuclear fuel. Okay, so it's amazing if you look at it, except for once you read the disadvantages, you realize why something this good is not being used often. The problem with nuclear energy is that it produces radioactive wastes. Okay, they take thousands of years to decay and must be and can be safely disposed. Okay, so you can't basically, first of all, you cannot have a nuclear electricity generating station near a city or near a place where people actually live, because the waste that it does don't get decayed right now in these years. No, they take a lot of time to get decayed, and you're kind of ruining the place for whatever creatures comes after, like thousands of years and stuff like that. And because at the same time, you gotta remember that they don't use big nuclear resources. Like it's not that huge. For you to generate electricity using nuclear resources, you barely need to have any nuclear fuel, and it will still work a lot. Okay, now if you keep reading the advantages, you're gonna find out that it says right there that the problem with all of that comes to the cost, okay, as they are expensive, all right, to both build and maintain. So even after you build it, in order for you to maintain a power station that works with nuclear energy, it's not easy, all right. And working with them is described to be not easy to be turned off on and on quickly, okay. And so it cannot respond to changes in demand, meaning you can't just, like, for example, one day you find out that the people want more electricity, you can't kind of increase the outcome or decrease it quickly. No. In details, I'm gonna not lie to you, I am not that experienced when it comes to nuclears, but those are the main disadvantages of it, which you can just like highlight in your brain and make them shorter in your head by saying that first of all, the factories are expensive to build and maintain. You can't turn them off and on quickly, so if a change in demand happens, you need a long time to react to it. And finally, they produce some waste that takes a lot of time to decay, but it's still a waste at the end of the day, and it's still not healthy, you know? Moving on to the next one, we're going to talk about biofuels, which are a healthier version of burning fuels. Okay, is it renewable? Yes, we said, because it comes from plants. All you need to do is just grow more plants, and you can use the ethanol and methane and whatever they have inside of them, so it is renewable. The CO2 released from the combustion, I'm talking about right now the advantages. The CO2 is released from the combustion is balanced by the CO2 absorbed in photosynthesis, so it could be considered a carbon neutral. Basically, yes, when you burn it, it releases CO2, but again, it's plants, so they also use it in photosynthesis, so it kind of balances out. In order to just say this whole point in an easy way, you can say that there is no carbon, I'm trying to find the right word, because there is carbon release. Okay, but you can say there is no carbon release to the, or I apologize, a better way to say it is the, hold on, the carbon release, what, why am I writing in blue? Sorry, clicked something on accident. You can say that the carbon you can say that the carbon release doesn't cause global warming, because if when you burn them, they produce carbon dioxide, but it gets used again and absorbed by photosynthesis, then basically whatever you're releasing is getting absorbed, so it doesn't even reach the higher layers of the atmosphere in order to cause global warming or whatever it is. Now, the bad stuff about it is that it says land and resources used to grow crops are needed to grow food crops. So you need a huge amount of land, because again, you need plants to produce biofuels. So you need a lot of lands, and then you need to start planting plants to do this stuff. So it's not very, I don't know, like if you think about it, you probably have better solutions than using biofuels, because the amount of land that you need to grow the plants on is ridiculous, you know, so you'd rather use something else. They don't ask much about it, by the way, and I don't know, it's one of the least used ways to generate electricity in the world in general. All right, moving on to the next one, we're going to talk about wind. And wind is wind is renewable. Okay, this is what the yes stands for. Okay, is it reliable? It's not reliable, because imagine if a day is not windy, then therefore you don't have wind, and no, you can't produce it. The good thing about it is that it produces no pollution at all. It's just basically a turbine that spins around every time the wind hits it, so you're not burning anything, nothing gets produced to the atmosphere, it's just something that's spinning, which is very healthy. So it produces no pollution or CO2, and they are cheaper to build to and maintain. You don't need huge lands. They are a bit expensive, but like by saying cheap right here, it means that once you put them, that's it. Like considering the amount of electricity you can generate by them, you can say that they're pretty cheap. All right. Now, when it comes to advantages, the most important ones you just need to keep in mind is that they are no pollution, cheap. All right. Going to the disadvantages, you're going to focus on some other stuff it's not reliable, meaning that if the day doesn't have wind, or if the place is not known to be windy, then you can generate from it. And you can only, as it explains it right here, it says you only generate electricity when the wind is blowing in a certain direction. Okay, some people consider them visual pollution, just calling them ugly here by saying they are visual pollution. You're just saying ugly. You can also add another disadvantage, by the way. You can just not stick to those two, and it would also count correct in any question. The problem with wind electricity generating is you cannot control based on the demand. Like one day people want a lot of electricity, you can't just go to the wind and tell it to move faster. You know, the best thing you can do is build more windmills, but you can't do that instantly. So you cannot change the amount of energy you generate depending on the demand. That's not something that you can do. While when it comes to fossil fuels, if you remember up here, you can always do that. You know, you can just burn more fossil fuels, spin the turbines more, generate more electricity. Here, you're just dependent on something that's not even in your control, which is the wind. Right. Next one, hydroelectric. Is it renewable? Yes, it is. Okay, because you're not burning anything, you're not getting waste of anything. And if you remember with me, the hydroelectric, the way it works, it's basically spinning a turbine using water, but you need to be dropping water from a high place to a low place, if that makes sense. Using a dam or something. So imagine if you have a dam right here and the dam was holding the water all the way. If you release some of the water from a pipe or from a, I don't know, like you give it a gap for the water to run through, and you place a turbine right here. Okay, this water is gonna hit the turbine, it's gonna make it start to turn, and the moment it turns, it can generate electricity. All right, so it is reliable. And the reason it's reliable is as long as your dam is filled up with water, you can drop the water and close this gate whenever you want to, and open it whenever you want to. You don't care if it's raining outside, you don't care whatever is happening, it's in your control basically. Okay. You can respond to meet changes in demand, meaning that you can basically push more water from the dam downwards if you want to generate a lot of electricity. And if you don't, then just don't do that. Push little amounts of water. Okay. No pollution. It doesn't produce CO2. Okay. Unless the pump is used to return the water. This is a very, 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 very special case that you don't need to worry about. And it's saying, imagine if all the water that you push down here, you want to return it back to the top, you need to use a pump, and the pump needs energy, which is something that's going to use fossil fuels. It's a very deep idea that you don't need to worry about. The idea of it is while it operates, it does not produce pollution and it does not produce CO2. Now, the bad stuff when it comes to hydroelectric energy generating, it says that it can involve flooding large areas to build reservoirs, which destroys the habitats and displaces wildlife. It's not as deep as it mentions it. The bad thing is it takes a lot of space. Water might flood to the left and right, which is, yeah, you know, floods destroy a lot of trees. It might end up in a disaster, you know. It's not something that happens usually, but it might happen in a disaster if you know, not control the water in the dam very well, because you need to build a dam and you need to fill it up with water. If it rains, you'll have more water than expected. It might cause a flood to the surrounding. All right. Moving on to tidal. It's again using water, but you don't need to build a dam and everything. You just need to rely on the tides that get created either by people or tides that are created by nature, right? So is it renewable? Yes, it is. Tides get created always, and they will never run out. Okay, by tides it means waves, by the way here. Tides are very predictable, which is something good. You know which countries have a lot of tides and which countries don't. That's why people who also do surfing, water surfing or tide surfing, or wave surfing, whatever it's called, they do it in certain countries. They know those countries have waves. Now, I've never seen anybody do it here in Libya. I don't think we have waves that high. Okay. So energy can be produced at regular intervals, because you kind of can predict whatever tides happen here, even though this is not guaranteed 100%, but it works. Few suitable locations can harm aquatic life and disturb shipping. It's just saying that if you build it right there, you might disturb the ships moving and you might disturb the fish life. Okay. Again, those are not, by the time I finish all of them, I'll tell you the important ones they usually ask about more than others. Okay. Geothermal, energy that comes from deep layers underground. Okay. Is it renewable? The answer is yes. Is it reliable? The answer is also yes. And the bad thing about it is not many suitable locations, because in order for you to find a place underground that's very hot and it's not too deep, you gotta be at certain positions. So you can't build a geothermal power station anywhere. Okay, and the burning can also release methane that comes down from the basically when you pour the water down there and it turns into smoke. Some of the smoke will also it turns into steam. The steam is not going to be clear. Some of it will have methane with it, which is, a greenhouse gas, and it will ruin the environment. Lastly, we have the solar. Renewable, yes. Okay. Is it reliable? No. Not reliable at all. Produces no pollution, which is nice. No greenhouse gases, nice. Good for electricity production in remote areas. So if you notice that your country rarely gets clouds, your country rarely, like if you're in the desert, for example, you only can predict nighttime to come at night, obviously, and that's probably the only time where sunlight won't be hitting the solar panels, making it very, very good here. But you still are gonna have some days where it rains, some days where it gets a bit cloudy. That will happen, but most of the time it's good. But because that happens, you can't say it's reliable. So the answer is it's not reliable due to that. And it only generates electricity when the sun is shining, obviously. Each solar cell can produce only a small amount of electricity, so many cells are needed. And this is whenever you see a picture of a power station that uses solar panels, you find a lot of them placed. Okay, so the bad thing about it is that you need a lot of solar cells in order for you to create a lot of electricity. That basically ends it up for this chapter. It's not a hard one. Okay, we're just gonna go over questions to cover it up, but one more time, I just want you to remember that the important ones you might face often are fossil fuels and nuclear fuels. They're very similar to be the non-renewable ones that usually burn stuff to create electricity. Biofuels, not as much. Wind is being mentioned sometimes, not as much either. Hydroelectric, yes. And then lastly, geothermal and solar. The rest, you might face them, but it's very rare, okay? Alright, just to display the type of question that you might face regarding the topics that we mentioned, I brought like 4 questions real quick to go over them. First one says that this diagram shows a type of power station used to generate electricity. You can see that it's something that basically pushes water down. Okay, I think I'll highlight it better so you can see it. You can just say that it's something that pushes water down, and once the water reaches the bottom, it gets hot, and then it rises up as steam, and it enters the turbine, and it spins it, generating electricity, and then, takes it outside. We discussed this type of energy resource, which pushes water under to the deeper layers of the ground to use the heat that's under there to generate electricity. We described it to be geothermal energy resource. So right here it asks you what's the type of renewable resource does this power station use? It uses geothermal energy resource. Okay. And it says name another renewable resource. You can name anyone that comes to your mind. The first one that came to my mind is solar energy. Okay. An easy question just to show you. Like, it just displayed the diagram to you and it asks you what energy resource are we using right here. We're using geothermal energy. All right. Another question, it says a coal-fired power station and a wind turbine both produce electric power. So you have coal, which is fossil fuels, and you also have a wind turbine. They're working together. The power station produces 1,200 megawatts, and the wind turbine produces 1.5 megawatts. All right. Remember with me that mega means a million. So the power station with the one with the fossil fuel, it produces 1,200 million watts, which is a huge number. Comparing it to the wind turbine, which only produces 1.5 million watts. All right. Give one advantage of using wind turbines instead of coal power stations to produce electricity. The only good thing that you can say that the wind turbine does, which the coal-fired power station doesn't, the one that uses fossil fuels, is you can say that it's clean. Or you could just say doesn't produce greenhouse gases. Or another student might look at the wind and the windmill, and you can just answer by saying that it's renewable. It's up to you. All the answers would count as correct. If you said it's renewable, it's alright. If you said it doesn't produce greenhouse, clean also follows the same thing, so it's alright. Coal-fired power stations are still in general use. They're the ones that are being used more often. Explain why wind turbines have not replaced them. And you can use the whatever points you didn't use up here, you can use them down there by saying, for example, that the problem with wind turbines is the fact that they don't produce as much energy as the power stations and they're not reliable. And you can say the good stuff about the power station, the one that uses fossil fuels. You can say that it's reliable, it has bigger production, even though it releases greenhouse gases, but it covers up with other stuff. So you're just gonna make a small comparison between the power station and the wind turbine. And after you compare both of them with 4 points, you're gonna get the mark for the question. You can always revise such questions from the points that we discussed right here. Okay, and in this case, you're gonna call the bad stuff about the wind and the good stuff about the fossil fuels, because it's asking you why did the wind not replace fossil fuels yet. So you just need to basically answer with the bad stuff about the wind. You can say because the wind is not reliable and it can only generate electricity when the wind is blowing in a certain direction. And some people consider them visual pollution, calling them ugly or whatever. And you can say that the power stations using fossil fuels are still here because they're reliable and they produce large amounts of energy consistently and can change depending on the demand. This would answer to you the question of why are coal-fired power stations still used instead of the wind turbines. All right. Another question here. It says in 2013, the UK government decided to build another nuclear power station at that location. And this is the third nuclear power station on the site. Discuss the advantages and disadvantages of nuclear and biomass power stations. Again, you just need to go up there because it said advantages and disadvantages. Start with nuclear, talk about the advantages of it, saying that it's reliable and it produces large amounts of energy. Okay, and no pollution or CO2. All right, and this just tells you that also you can add also large amounts of energy produced with small amounts of fuel, whatever you want to talk about from the advantages. Go to the disadvantages, say that it produces radioactive wastes and they decay thousands of years later. They're expensive, okay, and they cannot be turned on and off quickly. Now, you go to biofuels because it also spoke about bioenergy in general, and you start talking about their advantages and disadvantages. The CO2 release is balanced, meaning they don't release any CO2 to the CO does not contribute to global warming, which is a good thing. The bad thing is the amount of land and resources that you need. It's just like most questions when it comes to this lesson, it's asking you to compare between two energy resources. Last question we have here, it says that the first part of the question I forgot to write on top or include here. It says that basically there is a company and this company is going to build an extra power station, and it has two options, which are geothermal power station or a solar power station. It asks you explain how the location and climate may affect the type of power station that the company chooses in this case. All right, so you just need to talk about both of them. When it comes to location and climate, how would that affect what power station the company chooses in such a thing? We know that geothermal can only be built in some places in the world. We discussed that in its disadvantages because you can't put it anywhere in the world. You need a place where the layers of earth get very hot without going super deep. Again, solar power, when it comes to the location, you need a place that's sunny. Imagine building a solar power station in the UK. Obviously, that wouldn't work because it's cloudy and it rains there. All right, and then move on to the climate. It's pretty much the same ideas you're going to repeat right here. I'll find the mark scheme of this question right here, the correct answers that are accepted and not accepted. Give me a second, I'll attach them so we can go over them. All right, so this is the mark scheme of the question displayed up there. It compares both of them when it comes to the location first. It just tells you that, you need a place that has high sun angle. It needs to be a lot of area in order for you to place solar panels, because you can only produce energy or electricity if you place a lot of them. And if you're doing it with geothermal, you need to place it somewhere where you actually have hot water and heat underground and whatever it comes to that. And it needs to be away from people to whatever smoke it releases. Climate-wise, solar panels are affected by seasons. Some places don't have sunlight all time in the year. Hours of sunlight, as some places have more daytime than others. And finally, it's just like it's telling you the geothermal power stations are unaffected by any climate, as everything happens underground. So as long as you choose a good location, you don't care really about what happens on the climate outside. If it rains, if the sunlight is blocked, that's not something you're concerned with, because you just need to choose a location that has layers of the layers underground are hot, and therefore you can produce using geothermal energy. Here it gives you some notes saying that some extra stuff are allowed, but that's only in case you don't use the ones I mentioned here already. That should be all for the video. Thank you for listening, and see you next time.